Hello everyone, welcome to TA. In today's lecture of science and dispersion of light. Earlier of refraction of light, second two videos. Third video and the topic in understood refraction of light. Refraction is the bending of rays when it travels from one medium to another medium. As the ray of light travels from one medium to another medium, it changes its path. Along with the change of path, the ray of light speed changes. This is refraction. Based on that concept, we have studied something about incident ray, refracted ray and normal. Let's revise this one more time. In previous video, you have seen about this sort of thing, wherein a glass was there, incident ray, refracted ray and normal was there. The same example is over here. This one is known as incident ray. This is point of incidence. This is point of incidence. At the point of incidence, we draw a normal. That normal is perpendicular to the surface, perpendicular to the boundary separating two medium, and this is refracted ray. You can see this is ray of light and this is another ray of light. Here the ray of light has changes its path. Along with the change of path, this velocity of light got changed. This we have studied. Now, based on that concept, we have certain laws of refraction. This concept is not there in your syllabus, and for a time being, you won't understand with that much level. So, if you don't understand, don't get confused over here. So, but still we have to cover the concept of refractive index. In order to study a refractive index, we should know something about laws of refraction. In laws of refraction, we have two laws. This one is first law and this one is second law. What does first law says? This the incident ray, the refracted ray and the normal to the refracting surface at the point of incidence all lie in same plane. What do you mean by this? First we will see what do you mean by same plane. You might have undergone something about axis. Now what do you mean by axis? In mathematical classes, you might have observed this one, this portion. If I consider this screen as in terms of axis, so this would be my x-axis and this would be my y-axis. Either way you can take, even you can take this one as y-axis and this one as x-axis. It doesn't matter. Since I'm considering this axis as x-axis and this axis as a y-axis, so which means my object is a two-dimensional plane. Two-dimensional plane means whatever I'm doing, I can do only in terms of two axes, this x-axis and y-axis. I cannot come out of my screen. So the working area of my place is two-dimensional plane. With the same emphasis, if I say about three-dimensional plane, in three-dimensional plane I will have x-axis, y-axis and another I will have third axis, that is z-axis. The z-axis will come outside my screen. So my working area would be x-axis, y-axis and z-axis above the surface of screen. So that in this sort of situation, you will say my working area is three-dimensional plane. Again, you don't have to go that much detail into this at this point of time. Simply you have to understand same plane. Same plane means the incident ray, the refracted ray and normal all will lie in single plane. There will be no different planes. This is first law of refraction. This one is second law of refraction. For a given pair of medium, the given pair of medium means at least there should exist two medium minima. there's a possibility that there's a strong possibility that even 3 to 4 mediums can occur. 3 to 4 different mediums like air, water, kerosene. These are different mediums, and the behavior of light in air would be different, behavior of light in water would be different, and behavior of light in kerosene would be different. Again, there are different pairs of medium. So here, for a given pair of medium, the ray of light, for a time being, avoid this wavelength term. Wavelength term you will understand in when you will study something about sound. For a time being, avoid the concept of wavelength. For a given pair of medium, the ratio of sine of angle of incidence to sine of angle of refraction is constant. What do you mean by sine of angle of incidence? If we draw an angle between normal and incident ray, this angle, this I portion is known as angle of incidence. Always, angle of incidence is always drawn from normal towards incident ray. With the same emphasis, angle of refraction is drawn from normal towards refracted ray. So this portion is angle of refraction and this one is angle of incidence. And if I take a function that is sine, why I am taking sine function, why not cos function, why not tan function, you will come to know in high standard. If I take the concept of sine I upon sine r, I will always get a constant. What do you mean by this? If I take this angle, if I take a protractor over here and measure angle with incident ray, I will get a value, suppose 30 degree. So it would be sine 30 degree. With the same emphasis, if I kept my protractor over here and measure this angle, r portion, I will get sine r. Suppose this is 30 degree, this is 18 degree. If I divide sine 30 degree upon sine 80 degree, I will get a constant. Which means, what was the medium? If this was air, this was water. So the refractive index of water, how can I get that? I will get, if I divide sin I upon sin r, I will always get a constant. This constant will always remain forever. Whenever I take a pair of medium, that is air and water, if I take this sort of combination, I will always get a constant. So that constant is nothing but refractive index of water. If I consider this medium as water, if I take sin I upon sin r, I will get refractive index of water. The same thing is explained over here. The refractive index, the ratio of speed of light in a given pair of medium, give us the magnitude of amount of bending. What do you mean by ratio? You have to divide certain thing upon certain thing. So the ratio of speed of light in a given pair of medium give us the magnitude. Now what do you mean by magnitude? Magnitude is simply a number. Whenever you encounter with the word of magnitude, magnitude is nothing, always remember it is a number. In higher classes and whatever concept you study in terms of science, you will always heard this sort of concept, that is magnitude. Always remember it is a number. So the ratio of speed of light in a given pair of medium. So if this was my first medium and this was my second medium, the speed of light in this medium and speed of light in this medium give us the magnitude of the amount of bending. How much bending will take place is determined if I take the speed of light for a given pair of medium. So this thing is nothing but a relative refractive index for a medium. Why this relative refractive index? Because I am relating two medium, that's why I am using relative refractive index. And another, in terms of physics, refractive index is always denoted by this sign. This sign is known as mu, mu. How to draw this? You will draw this in this particular manner, mu. You can even write mu or eta. Eta is simply written as n, or you can extend this line of n to some extent. So refractive index is always denoted by mu or eta. You can use either of the sign. So this sign is known as mu. And how to read this? Refractive index of medium 1 with respect to medium 2 is given by this sort of thing. Again, there are different procedure of writing this refractive index of medium 1 with respect to 2. In higher classes, you will come to know about how to write this in different situations and how to solve numerical based on the concept of refractive index. Basically, you will understand this concept more precisely in 10th standard. How to solve numerical based on this, how to write sign based on this concept. For a time being, what is refractive index? Refractive index is the speed of light in medium 1 upon speed of light in medium 2. So we know that speed of light in medium is denoted by V. The speed of light in medium 1 means velocity of light. It is denoted by V. Since medium is 1, therefore we are writing V1. Speed of light in medium 2, speed of light is denoted by V, and medium is 2, therefore in suffix I am writing V2. So if I divide V1 upon V2, I will get a constant. That constant is refractive index, and it is written as with this particular sign. This sign is known as mu. Now, second thing, that is absolute refractive index. Earlier it was relative refractive index, and this is absolute refractive index. So what is absolute refractive index? Again, it is quite similar to relative refractive index, but in this case it is always speed of light in vacuum. It is always the ratio of speed of light in vacuum to the speed of light in medium. In previous case, it was speed of light in medium 1 upon speed of light in medium 2. In relative refractive index, it is always speed of light in vacuum first upon speed of light in medium. In short, you can say in numerator, you will always find the speed of light in vacuum. That is a constant value. You might have known about it. Speed of light in vacuum is approximately 3 into 10 to the power 8 meter per second. That is denoted by the velocity of light in vacuum is denoted by a specific symbol. That symbol is nothing but c. So speed of light in vacuum upon speed of light in medium. Here m stands for speed of light in medium. V means velocity. Velocity can either be written as V. You will come to know why we are writing V, why not S in higher classes. So in here, speed of light in a given medium is written as V, and medium m, therefore in suffix we are writing as m. So what is absolute refractive index? It is denoted by again this sign. Here in prefix I am not writing anything as such. In previous case, in prefix this portion is known as, year 1 is known as suffix, and this 2 portion is known as prefix. You might have known about it. So in absolute refractive index, the suffix is m, and in prefix nothing is written. So in this way you write absolute refractive index. This sign is again mu. So what is absolute refractive index? Speed of light in vacuum upon speed of light in medium. I hope you have understood the concept of refractive index. I've tried my level best so that you can understand the concept of refractive index. Whatever queries you have, do comment and write. I will try to help you out with it. Now the next concept, that is real and apparent depth. As you can see in this picture, a person is standing over here and a sea of water, this portion is known as what, this is water, and he is trying to observe a wooden object. So what he will observe is based on real and apparent depth. So the real depth means the actual depth. If we consider this situation in terms of sea, if this is a sea and the person is observing certain object in sea, so from this portion of sea to this portion of sea, this is the real depth of sea. And if certain object, if a person is observing certain object, whatever he or she observes, that would be called as apparent depth. Apparent depth means not real depth but a false depth. He will see a false depth but he will not see the real depth. Real depth is this one, the actual depth of sea. So what exactly this situation tell us? In water bodies, object appears less deep than it actually is. If a person, if an outsider is observing certain object in water, he or she will observe that object little higher. This was the bottom portion. This person will observe this object little upward. Why is it so? Because of refraction of light. Here, the rays of light is going from denser medium to a rarer medium. Here, the denser medium is water and the rarer medium is air. Air is more denser than water and ray of light is going from denser medium to a rarer medium. You can understand with the help of this arrow. Ray of light is going from denser medium to a rarer medium. When a ray of light goes from denser medium to a rarer medium, it bends away from the normal. This is the normal, it is bending away from the normal. So this thing is away from the normal, and as a result of which this object, it will appear little upward portion to this person. That is the apparent depth of the object. He will observe that this box is little upward. That is the apparent depth he will observe. That is, this is written over here. In figure, light bends away from the normal. From the observer, ray of light is going from optically denser medium to optically rarer medium, because of which this person is observing this object little upper. So from this portion to this portion is the apparent depth, and the real depth is this actual depth. Why is it apparent depth is arising? Because ray of light is going from a denser medium to a rarer medium in this person eye. As a result, this object will appear little upward to this person. This is the apparent depth. Thank you. In next video, we will understand something about refraction through a glass slab.